Hello, my friends. I am terrified of this thing because I just recorded this in under 10 minutes and I forgot to have sound on. So let's hope this one will work and I can still stay under 10 minutes. We'll find out. You looked right now. I saw you look. You looked. But I'm Mr. Folly and welcome to Acids and Bases. So acidity, first of all, acidity is a measure of H positive. H positive is the exact same thing as H3O positive. And it's the exact same thing as a proton. So that means H positive concentration equals H3O positive concentration all day, every day, right? I say it's like your parents and Santa Claus, right? Now remember, a proton is the same thing. So it said, what's the concentration of a proton? That's that, okay? And remember, acids and bases are always aqueous. So HCl, we're used to calling hydrochloric acid. But if, and it rarely happens, but happens, if it's a gas, that wouldn't be called an acid. That would not be hydrochloric acid. That would be hydrogen chloride. So remember, acids and bases are always aqueous. All right, so let's take a look at this. Acids, the definition of an acid in AP chemistry is that acids are H positive donors. Do you see how this H right here is going to be donated over here? And then look, oh my goodness, this base now has an H positive on it. Looky. Okay, this is a base. So what's a base? A base is an H positive receiver. This base right here received a hydrogen. Oh my goodness gracious. Look, it received a hydrogen. So this transferred into something that gained a hydrogen. And this transferred into something that didn't transfer. That probably isn't the best word there, but you get the idea. As H positive goes up, OH negative goes down. That's like as you get richer, you get less po, right? When H positive equals OH negative, the solution is always neutral, but it is not always pH 7. Okay, so we'll get into that. I think it's lecture 2 or 3. We talk about how water does some weird things. Equations we need to know. Dun, 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 dun. These are on your equation sheet. Please get out your equation sheet now. We're going to refer to these, and I'm going to pretend you just know where they are. There's a section called acids and bases on your equation sheet, and I'm just going to refer to these like you have them memorized, like you will. All right. Acids have a pH below 7. Bases have a pH above 7. Neutral has a pH of 7 at 25. Negative pHs are okay. pH above 14 is okay. Okay. It's not the most common thing on Earth. That's an okay. But it does happen. All right. Strong acids. What makes that strong acid? We should know this. We've talked about this a bunch. Strong acid ionizes 100%. So that means if I'm looking at HCl, remember how I say I don't even think of that as HCl. I think of it as H positive plus Cl negative because that happens 100% of the time. Okay, but if I'm thinking of a weak acid, HF is a weak acid, aqueous, I need to think of that as HF together. It's a weak acid. It only ionizes 5% or less. So it ionizes 5% or less. That means it's 95% unchanged, right? But strong acids, 100%. I meant what I said. I said what I meant. A strong acid ionizes 100%. That is from, that'll be your bonus question on the podcast. What cheesy Dr. Seuss thing is that from? Some elephant. I forget. All right. Ka is the equilibrium constant for an acid. Every K is the same. Products over reactants raised to their coefficients, leaving out solids and liquids. And for this one, water is usually involved in the equation. So omit means leave out water. Ka is close to infinity because remember, if it's a strong acid, my reactants, remember how I crossed this guy out? My reactants are really close to 0. And these are really close to, let's say if I did 1 molar, 1 molar, 1 molar, right? And this would be 0.0000000000001, right? And divide by that, and it approaches infinity. Strong acids, boy, we did this a bunch. There's the names of them, make sure you know them. Acids typically start with an H positive or end in COOH. That is the carboxylic acid group we learned about in intermolecular forces. I just want to show this is a carboxylic acid group. So this up here is a carboxylic acid because it's H3COOH. This is the H always the H on the COO is the one that will be donated. Remember, say H givers or H donors. Sample problems. Calculate the pOH, that's not pH, of a 5.9 molar solution HCl. Hey, that's H positive, right? So if I'm 5.9 molar HCl, that means I'm 5.9 molar H positive. So the first thing I'm going to do is pH equals negative log of H positive. Negative log of 5.9 and negative log 5.9 is negative 0.77. Told you. See, there's some negative pHs. Now, this one asks for pOH. So I need to know that pH plus pOH equals 14. And negative 0.77 plus pOH equals 14. So pOH equals 14.77. See, I told you sometimes we'll get above 14, and sometimes we'll have negative numbers. Not too shabby. All right. Calculate the pH of a 0.022222 molar strong acid solution. I want to change my color. I'm feeling green. Okay. Where did I go? So I'm right here. So all I'm going to do for a strong acid, because it's a strong acid, that means that equals H positive concentration. So pH equals negative log 0.022. So negative log 0.022 is 1.65. There you go. Last one. Find the molarity of H3O positive and NO3 negative in 0.025 molar HNO3. Again, that's a strong acid. So that means it is 100% ions. So that means that it is 0.025 molar equals H positive, and that also equals the NO3 negative. Okay. Strong bases ionize 100%, just like strong acids. This is not true for weak bases. Weak bases do ice diagrams, which is a later lecture. Most typical bases in AP chemistry is RNH2. R stands for the rest of the molecule. Okay. But it's going to be an NH2 plus water or plus something, and it's going to turn to RNH3 positive plus OH negative. Okay, so this will do 100% completely for strong. Kp is the equilibrium constant for a base. Still, products over reactants raised to their coefficients. We would leave out liquid water. This would be aqueous, and of course, ions are aqueous. Okay, Kb approaches infinity for a strong base. Your strong bases are group 1 and 2 hydroxides. And bases either end in OH attached to a metal, or they end in NH something. All right, take a look. Find the pH of a mixture of 10 milliliters of 0.01 molar solution potassium hydroxide, KOH, and 10 milliliters of distilled water. So I'm mixing these two, so I'm diluting it, right? I'm just diluting it with water. So I'm going to do my dilution equation. M1V1 equals M2V2. My original molarity is 0.001. Whoops. And my original volume is 0.010. Remember, you gotta be in liters. Equals new molarity. And my new volume, since I added, and find the pH of a mixture. So I'm mixing, so I'm adding 10. So my new volume is 20. And I do my math, and I do 0.001 divided by 0.01 divided by 0.02, and I get, oops, I did not do that right, 0.001 times 0.01 divided by 0.02, and I get 5e negative 4 equals the molarity, and that equals KOH, which, by the way, would equal OH negative because it's strong, which, by the way, would equal K positive, which nobody cares about group 1 ions, but you do care that we're done, and maybe I went faster than last time. So to that, I will say, toodles.